Hello everyone. My name is Mohana Priya from the Department of Computer Science UG, Krista Jayanti College. So, today we will be discussing about an important topic from the course Digital Electronics, which is called as adder. So, what is adder, where it is used, how it is used, we'll be seeing that in this video. Adder. Adder is an addition of numbers which is done in the form of binary data, which is used in the digital circuits. So generally, addition is done using the numbers in mathematics. So when we are doing the addition in the digital devices or in the form of digital circuits, then we will be doing it in the form of binary format, which is adder. So, where it is used in many computers and in all other kinds of processors, adders are used to perform arithmetic logic unit. That is, inside the CPU, all these adders are used to perform the arithmetic logic units. They are also used in the parts of processors where these processors are doing a lots of calculations in the form of calculate addresses, table indexes, increment and decrement operators, and many other similar operations. So all these operations are done using adder. We will see how what are the adders available. There is half adder. So what is half adder? Half adder adds two single binary digits. It adds two single binary digits which can be named as A and B. So there are two inputs in the half adder and the output will be 2, which is sum and carry. The carry signal represents an overflow into the next digit of the multi-digit addition. So this carry is nothing but it will be carried to the next digit which is going to be added. So let's see the block diagram. If you can see, A and B on the left hand side are the inputs which is being sent or passed through the half adder circuit, and the output are the sum and carry on the right hand side. So sum is the output, carry is nothing but which will be sent to the next digit. So in the truth table, A and B are the two inputs, and these two inputs gives two outputs, which is sum and carry. So when input A is 0 and input B is 0, the sum is 0 and carry is also 0. When we add 0 plus 0, which is obviously the output is 1 or 2. When we add it in the normal form, it is 1 plus 1 might be 2. So, but in the binary form, it will be a little bit different. I'll tell you how it works. So, 0 plus 0 is 0. Sum is 0, carry is 0. 0 and 1, wherein when we add, sum is 1, carry is 0. And when input A is 1, B is 0, when we add 1 plus 0, the sum will be 1 and the carry will be 0. Now, let me show you how the addition works. So, 0 plus 0, which is 0. The sum is 0 and carry is also 0. So, there is no carry. So, this carry will also be 0. And 0 plus 1, which is 0 plus 1 will give you sum is 0 and carry will be 0 because there is no carry. And when some input A is 1 and B is 0, that is 1 plus 0 will give you 1 as sum, and carry will be 0. Now let's see how 1 plus 1 works out. You have to be careful in this only. So 1 plus 1, which is 1 plus 1 is sum is 0, carry is 1. So how does this happen? So 1 plus 1 generally in addition it is 2. So 2 is a number. How we will write this decimal number in form of binary format? So we'll be writing it in the form of 1, 0. So 1, 0 is considered as binary form, right? So wherein this last digit 0 is nothing but sum, and this 1 is nothing but carry. So this 2 is written in the form of 1 and 0. So 0 is sum, carry is 1. This is how we'll be getting 1 plus 1 is sum is 0, carry is 1. So next we will be seeing how we got the equation for the sum and carry carefully. Now when you see this sum, the sum equation is, when you see this particular sum column, you can see 0, 1, 1, 0. So now we have to only consider 1. Wherein if you see here in the second row, we have got 1. And beside that, we have to see the inputs, which is like when we see this 1, we have to see the inputs. What are the inputs that we have taken? So 0 and 1 are the inputs. So if it is 0, it is nothing but A bar. And if it is 1, it is B. So when a variable has got input as 0, we will be consider that as inverted, that is A bar. When the input is 1, then we will be considering it that variable as it is. So even the sum is 1, we can see that 0 and 1, which is A bar and B. Now let's see the second input which we got as 1, which is the inputs are 1 and 0. So 1 and 0 is nothing but 1 belongs to A. A means A, and it is not inverted because it is 1. So it won't be inverted. It is as it is A. When you see the second input, it is 0. So it will be considered as B bar, which is inverted. So when you see this equation A bar plus B, A bar, B plus A, B bar, which is in the form of A XOR B. So that is the equation of sum. Now let's see the equation for carry. Now what I told you, how you have to find the equation, we have to just see where the output has got 1. So if you see, the output is 1 at the last row. So now when we are forming an equation, we will see how it is formed. That is, we have to consider the inputs of the one that is available. So the inputs are 1 and 1. A is also 1, B is also 1. So we can directly write A, B. This is the equation for carry. I hope you have understood the truth table, how to form the equation from the truth table. Okay. Now let's go and find how to do the circuit diagram using this equation. That is, sum is A XOR B, carry is A into B. So circuit diagram, it is being simplified in the form of sum is A XOR B, carry is A into B. So A XOR B is nothing but XOR gate, right? It is XOR gate. So how the XOR gate is represented? XOR gate is represented in the form of this circuit, right? So wherein here the first input is A and the second input is B. So when you draw the circuit and when the inputs are passed, automatically the output will be A XOR B, right? This is sum. You can see A XOR B is already formed in this equation. Next is A into B. So if it is a dot product, which circuit will be using, which logic gate will be using? We'll be using add. Add is the logic gate that we'll be using. So A into B is nothing but we will be connecting A and we'll be connecting B and draw a AND gate which will be giving you A into B, which is carry input. Why we call it as carry input? As I told, carry is nothing but it will be carry output. Why will be calling it as carry output? Which is nothing but it will be giving the carry output to the next addition set as input. So I hope you have understood the circuit diagram, which is very much simple. You can find it through the truth table, and by forming the equation, we can find the circuit diagram. Next, we will be getting into the full adder. So full adder is nothing but it will be having 3 inputs, and these 3 inputs produce 2 outputs. So 3 inputs are nothing but the carry which I told, right, that will be going as an input of the third input. So first 2 inputs are A and B, and the third input is the input carry as Cin. And the output are sum and carry are the outputs. Okay. So in the third point, the output carry is designed as C out, and the normal outputs are designed as S, which is sum. These are the 2 inputs and outputs. So if you can see in this block diagram, so A, B are the 2 inputs and Cin is the third input. When it is passed through the full adder, you will be getting sum and carry output. Okay, it is called as carry out. Now we'll be getting inside the next slide, that is truth table. So when I'm discussing about the truth table, I'll be showing the truth table also. So A and B are the input variables. These variables are represented the 2 significant bits which are going to be added. So Cin is the third input which is represented the carry from the previous lower significant position. The carry bit is fetched. So as I told, A and B are the inputs and Cin is the input which will be coming from the previous addition. Okay, so sum and carry are the 2 outputs. So let's see how this truth table works. So A, B, and C are the inputs in which 0, 0, 0. If you pass 0, 0, 0 inside full adder, you'll be getting sum as 0, carry as 0. So 0, 0, 1 means you'll be getting sum as 1, carry as 0. I will be showing you how to add it. So 0 is the first input, 0 is the second input. So 0 plus 0 is 0. Okay, so when you add these both, 0 plus 0, you'll be getting output as 0. And when you add the output of the first 2 inputs to the Cin, that is 0 plus 1, which is 0 plus 1, you will be getting 1 as the sum and 0 as the carry. Okay. So similarly, we'll be doing the additions of all other steps. So if there is one input, if in the 3 inputs, if there is any one bit that is high, it means the sum will be high. Okay, now in this both 0, 0, 1 and 0, 1, 0, both the rows are having only one input high. So the sum is also high and the carry is low. So next, when we are seeing this row 0, 1, 1, if you can see, there are two inputs which is high. High is nothing but 1, low is nothing but 0. There are two high inputs. So when we are having two high inputs, let's see how the addition is happening. 0 plus 1. So these both we will be adding together first. 0 plus 1, which will be giving you 1 as output. 1 will be the output. So when we add this 1 to the Cin, that is when we are adding this 1 to the Cin, we will be getting 0 plus 1 plus 1 is nothing but 2, as I have told you. So 2, how you will be writing? 1, 0 in the binary format. So this one is carry and this 0 is the sum. So sum will be 0, carry will be 1. Similarly, the other steps also will be taking place, wherein 1, 0, 0 is 1, 0. That is one input is high, which means sum will be high. If there are two inputs high, then carry will be high. If you can see this and this, when it is high, carry is high. So 1, 1, 0, sum is 0, carry is 1. So when all the three inputs are high, both sum and carry will be high. I will show you how that works out. So when these both the inputs are added together, A and B, when they are added, 1 plus 1. So I told you 1 plus 1 is nothing but 1, 0, which is 2. So this is carry and this is sum. So to the sum digit or to the sum bit, we will be adding 1 to it. And the carry will also be added to it. Okay. So 0 plus 1 is 1. And 1 will be taken as the output to the next one. So if you can see left hand side, it is carry, right hand side, it is sum. So sum is also 1, carry is also 1. Okay, this is how we will be performing the simple full adder. And if we want to find the equation for this, as I have told y'all, if you want to find the equation, you have to first check for the sum. We will find the equation for the sum. When you are wanting to find the equation, you have to consider only the high outputs, that is 1. When you see 1 as output, you will be seeing the beside inputs. So 0, 0 is nothing but A bar and B bar plus the second input is 1, which is nothing but 0 and 1. 0 is nothing but A bar, 1 is B plus this third one, when you are seeing, it is A, B bar plus the last input, if you see, it is 1, 1, which is A and B. And when you are seeing the C also, you have to see. So C is 1, which is for the first equation, that is C is 1 means it is C. And for the second equation, it is 0, which is 0 means it is C bar. And when the third equation, it is 0, which is C bar. Again, in the last equation, if you can see, it is 1. So it is C. Sorry, I forgot to add it. So A bar, B bar, C plus A bar, B, C bar plus A, B bar, C bar plus A, B, C is the equation for the sum. Okay? Is the equation for the sum. And we will be even more simplifying this whole equation. If you can see, we will be simplifying it in the form of using K-map, we will be simplifying the sum. Okay, so the SOP form can be simplified using the K-map. If you can see, there it is having only 3 variables. So A, B, 3 are the inputs. So using 3 variables, if you want to build a K-map, it will be having 8 boxes, which is A bar, A, B, C. This is 0, this is 1, this is 2, and this is third box. This is 4, this is 5, this is 6, and this is 7. As we all know that A bar, B bar, B bar, C, B bar, C bar, B bar, C, BC bar, and BC is the format how we will be following. Because of that one digit change, we will be shifting the columns also as 0, 1, 3, 2, 4, 5, 7, and 6. So now if you can see, I had formed the equation which is A bar, B bar, C. When you see A bar, B bar, C, you have to put 1 in that box, and A, B, C bar 1, and then A, B bar, C as 1, and then A, B, C, that is the last equation we had got, right? That is 1. Okay. So when we are mapping it in this way, we have not found a pair where we can do any pairing. So why it is in this form? It is in the form of zigzag, right? So it is not at all having a pair. It will not be able to form a pair. So if it is in this form, so when it is in that form, we will be calling it as checkboard condition. So if that type of sum is having wherein we will not be able to have a pair, it is called as checkboard condition. So if it is in this form, we will be directly putting and wrapping this resultant in the form of XOR operations of the variable used. So whatever the variables are used, merge it or wrap it in the form of XOR. So there are only 3 variables which we have used A, B, and C in. So A, B, and C with the XOR in between, so which is being wrapped together. So next, if we are finding the equation for the carry, so if you can see for carry, we had got equation AC plus BC plus AB are the equations that we had got here. So if you can see in this one, this are the 4 things which we had got. So in this A bar, B, C, and here it is A, B bar, C, and in this last we will be getting A, B, C bar, and this one is A, B, C. So when we are getting A bar, B, C plus A, B bar, C, A, B, C bar plus last one is A, B, and C. Okay. Now, if you can see, this is the equation that we had got for carry, right? So when we have got it in that way, what we will be doing is we will be putting that in the K-map. So first, when you can see A, B, A bar, B, C. So where is A bar? A is here, and B, C, we have to put 1 in that position. Okay. And then A, B bar, C, A, B bar, C, we have to put another 1 in that box. And then A, B, C bar, A, B, C bar, will be putting 1 here. And A, B, C, so A, B, C. Okay, this is how we'll be getting. Okay, when we are putting these ones, we will be able to pair. Okay, there are 3 pairs that is formed, right? So A, B bar, in which we'll be getting, if we consider this pair, that is the first pair, which are common. BC is the only common variable. So we have written the BC. So when we are checking with the second pair is nothing but, this is the second pair. So when we are checking with the second pair, we will be only considering A. Okay, so when we are considering A is not common for both. And when you see here in this both, C is common in this both, right? So A and C. A is common for both the variables. So in this both, B bar and B will be cancelled, right? So C is the common variable. So A and C are the second term. And in the third term, for the third pair, if you can see, we will be finding this as the third pair, in which A is common again. And in this both, which and all are the common terms? B is the common term. C and C bar will be cancelled, ruled out. So A and B is the third term which we'll be getting for the equation, right? And then how we will be drawing the circuit diagram, as I told for the last one. So these are the product and sum. If you can see, A and C are the product which we'll be using add gate, AND gate. And here for all these terms together, we'll be using what gate? The OR gate, right? So A XOR B XOR C is nothing but, for A and B, if we are drawing one XOR gate, for A and B, if we are drawing one XOR gate, it will be formed in the form of A XOR B. Okay. Then to that, we have to add XOR C in also, right? So when we are giving this as input and C in as separate input using the XOR gate, we will be getting A XOR B XOR C, right? The first sum equation is being built using this circuit diagram. Okay. Now for carry, as I told you, A and C. First, we will be solving the term A and C. Okay, before we are drawing the circuit diagram, we have to further simplify this carry equation. So how we will be simplifying is that, so if you can see, there is a common term in this, both of the equation terms, which is, we see this, we will take this pair and this pair, A and AC and BC, we will be finding C as common, right? Which is C in is common, A plus B, which is A XOR B, and plus AB remains as it is. Okay, this is the final equation of carry. Okay, when we are doing this as final equation, then we will be drawing, first we will draw for A into B. So we will be connecting A and B with AND gate, that is dot product gate. And then for this, if you can see, A XOR B we are taking as one input, which is being connected from A. This is A XOR B, right? So when we are connecting this and C is another input which we will be connecting. So these both are dot product, which we will be drawing AND gate to it. So finally, if you can see, this and this both are different terms which is being used in the addition symbol, which is OR gate, right? So from this, the output will be connected. This is AB This is C into A XOR B. When we are connecting it with the OR gate, we will be getting C out as the output. This is the full adder circuit. Finally, everything in this we have found from the truth table itself. So if we are knowing the truth table thoroughly, we will be able to draw the circuit diagram and find the expressions for the sum and carry also. So if we are doing it in this way, we will be able to understand the digital electronics, half adder, full adder, and even more than that we can explore. So I hope you have understood. If you're having any doubt, you can do comment so that I can reply you all. And please like, share, and subscribe. Thank you.